is good enough. Is good enough. Because like I mentioned to you, hydrographic survey is not a critical application. You know what I mean? Critical application. I'm not saying it's not, it's not important. I'm saying it's not critical application. Why? If you don't get the signal from the GPS, well, you can go back home, right? And then you can eat your dinner, your breakfast, or whatever. Okay? So that's it. And then tomorrow you check your receiver, what's the problem? Oh, maybe there's a power problem and so on. Yeah. However, in the case of critical applications such as flight landing, if let's say GPS is not working because of the system, not because of your receiver, okay, not because of your receiver, because of the system, well, you still have a backup from the other positioning system, the satellite positioning system, such as the Beidou, the GLONASS, so on. Okay? Because if you don't get position in this kind of flight landing, right? That's a critical application. Right? Something bad might gonna happen if you don't have that position. Of course, they have radar. Yeah, of course they have radar. So that's answer your question.
Yes.
Any other question? Yes, please.
Kenapa dia boleh ikut L1 saja?
Kenapa dia boleh ikut L1 saja? Okay, now again, we are talking about want to reduce the cost. If let's say you are using both L1 and L2, right? Because you just want to get the position, okay? In order for your vessel, okay? Usually this GPS they use for the vessel navigation, hydrography, and other kind of navigation techniques, yeah? Navigation application. So L1 with code measurement is good enough. If let's say you want to add the L2, what does it mean? So that means you need to add the L2 tracking loop in your receiver. Okay. Number one, of course, the cost. Yeah, the cost. The second one, I'm thinking, if you put L1, you put L2, the receiver getting, bulky, maybe become bulky. Because for navigation, you want something small, easy to mobilize. Isn't it? Yeah. Answer your question?
Ada tak yang macam kita guna L1, dia guna L2, L5?
At the moment, no. Usually they go for L1. Why? That's a good question as well. Why not go for L2 or L5? Okay. See, L1 is the primary signal. If you remember, the frequency is 15 something megahertz. L2 is 12 something megahertz, right? The L5 is 1 something megahertz. I forgot the exact number. So the primary signal, because it's you got the highest frequency, right? It can reduce some of the effect. For example, the atmosphere, it depends on the frequency, right? So the higher the frequency, the better, right? Somehow it's better for the what we call it the signal propagation delay through the atmosphere and troposphere, and higher frequency compared than the lower frequency. That's why the L1 is the one that usually people choose. Okay, or the manufacturer choose in order to use this GPS receiver. Other question, please. Any question? Clear? Very clear? Crystal clear? Crystal. All right. Now, so if you want to go for 5 meters, less than 5 meters accuracy, you choose this kind of receiver. Okay, but you need to come up with extra money. Yeah, extra money. Later on, we will show you this type of it. This will be have it in. Yeah, we have it in. Alright. Next. Okay. So not the last one, okay. The surveying receiver. Okay, the surveying receiver. Well, the surveying grade receiver, surveying grade GPS receiver, or if you prefer GNSS receiver, okay, are mainly used for horizontal vertical measurement for boundary, topography, and so on. Okay, this is for surveying. Utilize at least single frequency. Okay? At least single frequency. Most of the receiver now they utilize dual frequency for the surveying grade receiver. Right? Of course, single frequency is cheaper than the dual frequency. Now, it can provide you high accuracy from few centimeter to decimeter level with a relative positioning. That means you need to have a reference station. That means you cannot operate the receiver, right? In order to get that accuracy using a single or standalone. You need to have at least two receivers. One act as a base or reference station. The other one act as the user. Go around. Now, keep in your mind, in order to get this kind of accuracy, we are not using the code measurement as our main measurement to calculate the position. We are using the carrier faces up. The carrier faces up. So now, by using this receiver, you can do it real time. You can get your position in real time. Of course, you need to have that base station just now, right? And there is another extra gadget that you need in order to do it real time. You need to have the communication element. You need to have the communication. Why? Because you need to transfer the base station data to the rover receiver. Right? Without that base station data, some people say correction. Some people say correction. You couldn't get this kind of accuracy. You need to have the data from the base station. Now, the other choice is you can post-process. That means you don't need the element of communication. That means once you have finished your survey work, right, then you bring back home, you download the data. That means you don't get your position instantaneous, in real time, like the first one just now. You bring back, you download the data, okay, and then you post-process. That means, post-process. However, you still need to download the data from the base station as well, because you're going to perform the relative. That's maintained. Okay, that's maintained. You want to use the relative. The only thing is that you don't do it in real time. Okay. Now, this type of receiver will cost you, less than 100K. Depends. Sometimes on the brand, okay. Sometimes on the function, okay. Sometimes the quality of the receiver. Like I mentioned to you, I asked this kind of question to my friend. He's one of the, working with the receiver manufacturer. I asked him, okay, which component of this receiver is the most expensive one? Is it the chip? Is it this one? This one? This one? He said no. The answer is, the casing. The casing of the receiver. That's it. That is to make it vacuum and so on. That is the expensive part and procedure. Okay. So now, okay, the price is less than 100K. 100K. On top of that, you must be very careful because some of these receiver, especially on real time, you need to have a reliable firmware. Okay? A reliable firmware. Because this receiver use the carrier phase as the main measurement. As I mentioned to you, right, the carrier phase, you need to solve what we call it the carrier phase ambiguity. Now, to solve this carrier phase ambiguity, you need the algorithm. The algorithm in the firmware will work, use the mathematics, use all the functions to estimate the most probable ambiguity parameter. And this is not an easy task. Usually, right? Usually, the receiver, they need the manufacturer, the receiver manufacturers, they need to test it many times. I got an experience. It's a cheap receiver, but when it comes to the ambiguity resolution, they're having a problem. I'll talk about this later on. Okay, when we come to the carrier phase measurement detail on the carrier phase measurement. All right, that's on the survey receiver. Any question? Any question? Is it clear? Clear? All right. Now, the last receiver type that we're going to discuss here is the geodetic type receiver. Right? The geodetic type receiver. So now, this receiver is used for high precision positioning and scientific application. The other receiver just now we use for surveying, right? For like mentioned just now, cadastral, topography survey and so on. But this type of receiver, they use for high precision positioning and scientific application, such as crustal and structural information, seismic survey, and atmospheric studies, right? Datum determination. Sounds like geodesy, isn't it? Yeah. Sounds like geodesy. You are talking about, millimeter, centimeter level accuracy. Okay? So now, they provide you high accuracy up to millimeter level with specific high precision software and processing technique. Yeah? You can achieve that kind of accuracy, right? Not just by the receiver only, right? But you need to combine it with a good processing software, and you must know the processing technique. Yeah? The processing technique. So you cannot just you measure, you switch on the receiver, you observe, and then you can straight away get the millimeter or centimeter accuracy. No. You must know how to process it. Right? How to process it. We're going to discuss this one on GPS next semester. Isn't it? Next semester? Okay. Next semester. Okay. So it's a combination. If you look here, it's a combination. The receiver, the processing technique, and then the software as well. Okay. Of course, in order to do this processing technique, you need to have the good software as well. Yeah? To run the algorithm and so on. If you can do your own software, it's okay then. But it's not that easy. It's not that easy. Yeah? It's not that easy. We call it, usually the software that we use, we call it highly scientific GNSS processing software. Yeah? It's not like a software, after this you do this. No. Right? You must know what you want to do. Yeah, you must know what you want to do. Okay. So now, the price of this receiver typically less than 50K. Right? look at this photo, you can see that, this type of geodetic receiver, they separate the antenna and the receiver. This is the antenna, this is the receiver. For example here, this is the antenna, and then the receiver is somewhere, they put it, they connect it in the small hut or whatever to record the data. So this is what we call it, for example, like this one, this is what we call it the radome. The radome. R-A-D-O-M-E. Radome. Okay. The function, for example, to reduce the effect of multipath. Yes, multipath is one of the errors in GPS or GNSS management observation. So now, they separate it. Right? They separate it. Why? Because it's not meant for people to go around and then measure. Like the previous receiver, surveying receiver. That one you can go around because in this type of receiver, right, the antenna, GPS antenna, and the receiver, they combine it together. If you look, there's a small antenna up here. That one is a radio link, the radio for communication between the base and then the rover. But the GPS antenna is here. The receiver as well in here. This type of receiver, okay, is separated. Antenna, you see the antenna is also look bulky, right? There's a reason why they design it like that, because they have a properties to reduce some errors, okay, some errors, in order to get a good, very precise measurement, okay. And usually this one they put it in the buildings or whatever. They use this type of receiver for a continuously operating reference station course, continuously operating reference station. Have you heard about MyRTK net? Yes. So the MyRTK net, they have a few reference station. If I'm not mistaken, they have 50 reference stations in Semenanjung and another 28 in Sabah and Sarawak. I think they want to install more stations. So the station, right? The station that they install, they use this kind of geodetic receiver, and it remains static and continuously observe the data. They don't move around. Right? They don't move around. Okay. Any questions? Any questions on the geodetic receiver? Is it clear? Clear enough, yeah? Okay then. Alright, so my assistant will show you the receiver. Okay. So Faiz, can you show them this receiver that we have? This is the geodetic receiver, the antenna. The antenna. Look like a flying saucer, isn't it? So it's not, coming from the space. Okay, it's quite heavy. Right? Don't drop this. I think the antenna itself costs about almost 20K. Right? That time, I think now they reduce the price. I think now they don't come up with this this brand. This type of I mean they have improved it. Okay, but this one's still useful. Okay, take it observe. Right? This is what we call it micro-centered L1, L2. Microcenter, L1, L2. Alright? So, see this, the antenna is here. This is the antenna. The receiver, okay. So, this is the antenna. We install it outdoor. Okay. So you can put your, your trash or whatever later on here, and then observe, study. This is the receiver. Okay, the receiver. So in order to connect this antenna to this receiver, okay, we need to use the cable. They have a standard cable 30 meters and 60 meters. If you go more than that, usually you need to have a preamp to amplify the signal, because the cable is too long. Usually 30 meters and 60 meters. So this antenna, because mentioned just now, microcenter L1 and L2, this is a dual frequency. Okay? You can observe dual frequency signal. And this receiver, they can process, they can decode the L1 and L2 as well as the code. And last time when we bought it, we bought it, this is about 150K. 150. This is the old type receiver, but still used. Any questions? You want to try to fool them? Be careful, don't drop it. All right. Alright, this is another type of receiver. So, alright, this is a surveying receiver. Alright, of course we have this, the code later on, you want to, because I don't mean to do surveying in this room, alright? So this is a surveying grade receiver, dual frequency. It has a capability to do RTK, real-time kinematic, real-time kinematic. So there is a port here where later on you can hook with the antenna, the radio link, in order to receive the data from the base station, the nearest base station. Usually, this radio antenna cannot go very far. It's about less than, from our experience with this equipment, less than 5 kilo. Less than 5 kilo. In fact, that one you need to set up the base station at high ground, in order to have a wide coverage. Wide coverage. So this is a dual frequency. You can do real time as well as you can download the data and do the process. It can process the carrier phase measurement as well as the code measurement. If you like, this receiver also can be a navigation receiver by just using the navigation, the code measurement. However, you see, you want to navigate, you want to bring this, go, left, right, go, and then right? Don't use this for the navigation for your navigation activity. That's why this was meant for surveying. Is it clear? Okay. The rest, yeah. So this is, you remember the data control just now? Yeah, the data control. In order to control this receiver, right? That's why you need to have the pole. Once you have the pole, you can have the receiver. See this receiver. You can have this receiver, and then they put it together here. Right? So you and then you survey in style. So you don't bring the pole, right? So you can attach this one to the pole, and then you can okay. Once again, right? You can do swing like this, right? Look professional then. Of course, our profession is we're talking about position. You are the number one. Okay, so you control it here. So the thing, let's say you want to do RTK, you need to key in all the parameters. Okay, you want to do surveying technique. What kind of surveying technique? You want to go for static, kinematic, whatever you need to control it here, and then you will pass to the receiver through the Bluetooth. They have a Bluetooth, or you can use the cable here. Be careful of this cap. There's a pin. Usually, students they just pull the spring very hard, and then somehow the pin inside here is get broken. Once broken, okay. This is the controller that you are looking for. Now, this is a DGPS type antenna. The receiver, this one, come together with the screen, because usually they put it on the vessel, okay, like a captain, you see, and then you can like a sonar, you can hook this with the sonar. They have a facility to hook this with the sonar, and you can get position from the GPS as well as the sonar. So, and then you can look again. Oh, got plenty of fish. Yeah. So, now the receiver is here, right? The antenna is this one. Looks small, right? Small. Of course, they have also other big antenna, right? So this is the antenna to receive the GPS, right? GPS. But this antenna must be combined with this antenna, right? This antenna function to receive the DGPS correction, right? DGPS correction from what I mentioned to you just now, the beacon or the reference station. So this receive the DGPS antenna from the beacon. They transmit the signal. The beacon transmits the signal. This one receive from satellite. Both data combine in this receiver and then process. Now this one is the we call it here automatic differential beacon receiver. Okay, automatic differential beacon receiver. That means one, hook here, and then from this point, connect to here. You see all the results from here. So that is the GPS and antenna. This is the GPS antenna. Right? Any questions on this? Any questions? Is it clear? Alright. Later on you can have a look and then you can ask my assistant. Okay? Alright. Now, last one. Okay? We go backward. Okay? From geodetic to the surveying grade, CGPS, and finally this is type of navigation receiver, code base, right? So here you can operate, the function almost like your handphone, the accuracy as well, right? The accuracy as well. Okay, so but this type of receiver is a bit special because you can slot a SIM card, and you can receive DGPS correction, because it's also allowed DGPS, right? You can receive a DGPS correction if the service provider can provide you with the internet-based correction, DGPS correction. Yeah, so you can use it. That kind of receiver DGPS is coming from the beacon. Yeah, this one got the option you can receive from the internet. Okay, so that is about the receiver that I've discussed with you. I'm sorry I cannot give you the military type of receiver. We don't have it. Yeah, we don't have it. Okay, so but I will show you navigation receiver, surveying receiver, the DGPS receiver, the surveying receiver, as well as the geodetic receiver. Any questions? Any question? Any question? So if you want to know further, you can ask my assistant, and then they will explain it to you, in details about this thing. Okay. We have Mr. Yusuf, my PhD student, and Mr. Faiz, my master's student. So I think you can switch on the light, then you guys can answer. Okay. So ask my assistant. I give you guys like 10 minutes to ask, then all the receivers. You can go. I mean, go.